Hey, I'm Adam Whalen, and this is my experiment for Eric Frohn's Flight Dynamics course, and this is my experimental setup. I have a piece of PVC tube here with some wooden ends to mimic an aircraft fuselage, and I have some strings attached to the center of gravity of the tube. And these strings will be used to pull the aircraft through the water. Just to show that they are indeed attached to the center of gravity. It does not rotate when it's picked up. And thus, it will be dragged across the water by a rope attached to the end of the floating device. And my hypothesis is that when this tube is pulled through different angles of attack or different initial conditions, that is, in the horizontal direction, that it will always tend to rotate itself towards the condition of highest drag, which would be pulling it across the water this direction. And that if we pulled it across the water in a strictly axial direction, it would be in a state of unstable equilibrium and tend to rotate towards the direction of highest drag. So this is the first part of my experiment, and I am showing how the aircraft responds when pulled through the water in a strictly horizontal direction. And as you can see, it does not rotate from this position. Okay, so this is the second part of my experiment in which I'm going to release the fuselage at a slight angle and see how it responds when pulled from the same direction. And as you can see, it returns to the state of highest drag from a horizontal direction. Hey, this is the third part of the experiment in which I'm going to release the fuselage from a high angle and see how it responds. And it still continues to rotate to the state of highest drag. Alright, so this is the last part of my experiment in which I'm going to release the fuselage in the axial direction and see how it responds to being pulled through the water. And while it does indeed to rotate, it starts off moving in the same position in a state of unstable equilibrium.